Hello and good morning and happy last week of prep. Today is Monday the 9th. Checking my calendar. It is August 9th. Look at that. Yes, this is the very last week of prep. So hopefully all of you are excited for that. I know I am, to see all of your wonderful projects that you've been working on the past few weeks. Also, that also means that we are almost done with math. So that's either exciting or sad or however you feel about that. But regardless, we only have a few days left with each other. So I appreciate all of you who have stuck with me for the entire way and who have been checking out the YouTube channel and stuff. So I know I greatly appreciate it, just because, it's nice to know that all the work that I've been putting in, right, has been reciprocated, and I see that. So thank you for turning in your homework assignments, and I'm trying to get that feedback back to you as fast as I possibly can. It's been a little bit challenging, but hopefully you could have seen last night. I believe I graded 2 or 3 of the homework assignments that were that you have submitted so far, and I think I'm still working on 5 and 6. So just keep a lookout for that. I'll have everything graded, and or like I'll have that feedback to you before Thursday, so at least you can go back and be like, oh, okay, I see that he said, oh, go back, check this problem. Everything's good. I'm good to go, right? A little bit about Thursday real quick. Yes, we're still having that mock exam on Thursday. I'm thinking I'll probably make it 10 questions. There might be like multiple parts to one question. For the most part, I'm going to try and make it straightforward. I'm not going to try and kill you with this mock exam. However, it is going to be a little bit more challenging than what we discuss in class. And on top of that, it probably will be more similar to your homework problems, if not a little bit more complex. Why? Because I want you to see the level of work that you're going to be expected to perform at for your actual midterms on your actual classes. So if anything, I'll most likely pull questions from different Math 1A tests that were actually given at Berkeley. Stuff that we've seen before, maybe just at a little bit more complex level that's, pretty standard level for your actual midterms, just so you can get a sense of what it's going to be like. So I don't want anyone stressing out. Again, I don't want you spending more than an hour Wednesday night studying for this, right? I don't want you freaking out. I'll give you a grade, and I'll break it down and stuff, but I don't want you freaking out, because at the end of the day, again, this is just to provide feedback for you and to just kind of help you see, okay, this is the level. Am I here, right? Am I at that level? And have I exceeded that level? Or, am I still a little bit below, and I just got to keep working within the next few weeks to get ready for Math 1A at Berkeley, right? So most likely it will be 10 questions, right? That'll make percentages really easy. So if I give you an 80%, chances are you probably got 8 out of 10 questions right. The majority of them will be pretty straightforward, and I'll try and make maybe 3 or 4 of them very complex. And when I mean very complex, I just mean like Berkeley math, like midterm level stuff. So expect that on Thursday. Again, Wednesday, we are going to try and review. So if we have to go into Wednesday a little bit, finishing up chapter 3.4, I believe is what I said I wanted to get to, we can go ahead and do that. And that's no big deal. So, but yeah, Wednesday, we'll try and get like an hour and a half review in. Also, if people want me to, I can go over some more practice problems on my own, record it, upload it to the YouTube channel, which, by the way, all the videos have been uploaded up until today. So especially the homework problem number 26, which I was grading last night. So if I made a comment, hey, go check out the YouTube channel. I think it's lecture 7.1. So other than that, plan for that. Let's talk about today. So yes, that is my drawing here of the Golden Gate Bridge with the Campany Lake Clock Tower. And that was supposed to be the Glade, and somehow the sun has overtaken half of the Earth. So I guess this is what, billions of years into the future. But that's okay, because by now we're on Mars, right? And so all of the engineers that are here with us today, all of us engineers, we have worked so diligently hard to progress our space programs and get to Mars, and now we have a civilization on Mars, right? So we are currently thriving on Mars while Earth has been engulfed by the sun. Anyways, yeah, no, that's not where I was going with that drawing at all, but I thought it was funny, so I said it. I laugh at my own jokes, but I think all of you were with me for improv, so I'm sure you can tell by now. Hopefully you all enjoyed that also, by the way. I know I had a blast working with all of the different groups. So let's talk a little bit about today. I want to share with you something that, I was talking about just a little bit earlier. Let me go ahead and share my screen here. Let me go ahead and, before I do that, try and find my Safari. Cool. Let me get to your website here. I want everyone to download this. You don't have to go right now, but it's on the B Courses website in the Math for Prep. I just uploaded a file. You might have been notified. It's in the files section. Okay, so it's in files. Let me share my screen just so everyone can see. Boom, there we go. I'm sharing my screen now. Hopefully everyone can see it. It's loading. All right, can everyone see that? I'll just assume yes, because I can't see any of the comments in the chat. Oh, there are none. Wonderful. Everyone's asleep. I'm kidding. So this is the B Courses website. Okay, this is Math for Prep. I wanted to share with you, I just uploaded this. This is the Math 1A, 1B full list of derivatives and integral rules. So you click on that. Hopefully it should open up here. Now you can see, all right, I wanted to show this to everyone. You can see I have uploaded every single derivative rule and integral rule that you could possibly ever use in your Math 1A and Math 1B classes. Now, your professors will go over this, right? These are all going to be different parts, like different sections throughout your book. But when you are studying for your final, right, you'll have your entire equation sheet right in front of you. Now, so whatever you do, go ahead, print it out, right? Keep it with you. If anything, if I want you to take anything from this class, even if you learned absolutely nothing and you fell asleep the entire time, please, please, please download this. It will help you in the future because there is no other list like it. I promise you. Your professors won't hand this out to you. You can't find it online, really. So I was blessed enough to have a teacher back in the day that created this for me, and I have now shared it with all of you. So try and keep this our little secret, because if this gets out, well, one of two things. If this gets out and gets back to my old teacher, there's a good chance I could get severely, well, let's just say things could go really bad. I don't think so, though, because I think it's accessible to the public, so I should be fine. But more importantly, right, the reason why I don't want you sharing it with other people is because, again, right, the Berkeley curve is real. And if you have a gigantic equation sheet that other students don't, right, you can see how this is going to help you in your classes and will make life much easier. So I know it might look foreign to some people now, especially those of you who never took like Calc BC or Calc AB, right? But again, you can see it has all the derivative rules, right? There's the derivative of sine, there's the derivative of cosine, tangent, secant u, cotangent, right? So on and so forth. It even has your basic derivative rules up here at the top, which we're going to talk about today. So I just want to share that with everybody. It's already integrated into the form of U substitution. So what does that mean? That means if you learned the substitution method and your professor or teacher never really taught you the U sub method, this is super powerful. So it might not make sense now. Hopefully by the end of tomorrow, it will. So I just wanted to share that with everybody. Hopefully that is a useful resource to you. I know it has been for me. So anyways, that is on the B Courses website. And yes, please, 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 if you can, download that, because I think I'll probably take it off by next week, by like the end of next week, just because of legality issues, even though this is recorded on YouTube. Anyways, probably should have confessed to that, right? Deny, deny, deny. What is that? Roderick, that one thing. Diary of a Wimpy Kid. There you go. Wonderful movie. Anyways, back to math, because that is what we are here for. All 45 of us. Look at that. 5 more people joined. Wonderful. Welcome. Let me go ahead and share my screen now. And unfortunately, my drawing has disappeared because I stopped sharing, but that's okay, because we are moving right along into section 3.1. For those of you that did the homework that I assigned on Friday, I went through and graded that really quickly as of last night. So I went ahead and provided that feedback. Pretty straightforward. For the most part, everyone got 100%. That was awesome. I think one quick thing, okay, I said take the derivative of x to the 34th divided by 34, okay? I kind of didn't talk about it, so I'll talk about it today a little bit. But when you take that derivative, right, you pull the 34 down in front. This becomes 34 minus 1 to the exponent, so that's just x to the 33, right? But that it's still divided by 34, right? It's still divided by 34, so those 34s cancel out. Boom, you're left with x to the 33. The majority of you got this. Wonderful. That leads us into our very next. Derivative rule that we are going to talk about today. Okay, so we talked about the basic generic form of a polynomial, right? A polynomial of degree n. We said that x to the n is any polynomial, right? And we said that the derivative d dx of x to the n, right, is simply this formula, right? X to the n minus 1, and we pull the n down here in front, okay? That's what we got to on Friday. Perfect, right? So if you remember, we had that really long limit equation, right? We said the derivative is equal to the limit as h approaches 0 of, I think it was like f of h plus x minus f of x all over h, right? Something like that. And we said this is also the derivative, right? But as we started taking the derivative using that limit form, okay, we realized real quick, hold on a second, there's a much easier and simpler way to do this, right? We're no longer taking limits, we're dealing with derivative rules, and we are very thankful for that, because if we had to do limits for all these crazy complex derivatives, it would really suck. So we found that, oh, this is a generic form that we can use for polynomials of degree n. Cool. Let's talk about our next derivative rule. Case in point, okay, the derivative of x squared, okay, d dx, remember I said there's different notation. I'm going to use d dx of x squared. That is simply n is equal to 2 here, pull down the 2. Now this becomes x to the 2 minus 1, which is just x to the 1 power. I'm going to write it as 2x. Problem solved. That's the derivative. See how easy that was? No more limits. Yay. Okay, so that's our first rule. The next rule, let's talk about constants, okay? d dx of c times x to the n, okay? Where c is a constant. C is equal to a constant. What do I mean by that? It can be any number, a fraction, a decimal, doesn't matter. Negative, positive, cool. It's a number. We calculate this the same way, okay? We can actually calculate it like this. We can pull that constant out, then we can take the derivative d dx of x to the n. Does everyone see that? In other words, we pull the constant out in front, and we are left with the derivative of x to the n, which we know because it's right up here. That's our derivative rule, okay? So I'm just going to give you a quick example, okay? Let's say we have 5x squared. I want to take the derivative of it. The derivative would be, all right, we still have that constant out here. Now we just take the derivative of x squared, which we just solved for, right? We said that is 2x to the 1 power. So I'm just going to write it as 2x, okay? We pull that 2 down in front. The 2 multiplies the x, but that 5 is still multiplying the 2. 5 times 2 is 10. There you go. That is our constant rule. Pretty straightforward, pretty simple. Just remember that. On the equation sheet that I gave you, I believe it talks about it in terms of, I lost it here. That's wonderful. That's fine. We talked about it. It just uses k. K is a constant because apparently you spell constant with a k. I'm kidding. But yeah, so that is how you do that. Yes, question really quick. Go for it.
Yeah, did you just drop the exponent to the side?
Correct. So, okay, so using this formula, right, that we derived on Friday, okay, using this formula that we derived on Friday, we said that the derivative of x to the n, where n is the exponential number, right, you take the derivative, you pull that number, you put it in front of the x, then you take that exponent and you subtract 1 for it, boom, that's the derivative, okay? So if we had x cubed, right, the derivative is simply 3x to the 3 minus 1 power, which is 2, okay? 3x squared, okay? So that's all I did. I pulled the 2 down in front, but there was a 5 multiplied in front of it by our constant rule, right? Now I'm just giving you rules. all I need you to do is just remember how to use these rules, right? I'm no longer going to go ahead and prove all of these rules because at this point, sections 3.1 and 3.2 give you about 10 or 12 of them. And I don't think everyone wants to see those proofs, okay? So just trust me that when I say you can pull the constant out in front, right? And then you just multiply it back in. But yeah, the way that I got that original number, you just pull it down based off of this formula up here. So hopefully that clears things up. But all right, so we talked about the constant rule, our basic generic rule. Let's talk about now, the derivative of a constant, d dx, okay, of c. All right, again, we said c is a constant, okay? The derivative of any constant is just 0. All right, so any number, okay, what's the derivative of 5? The derivative of 5 is equal to 0. What's the derivative of 10 billion? That's 0, okay? Let me give you a graphical example really quick. We said that when we take the derivative, that is equal to the slope of the tangent line. Well, let's say y equals 5. What is y prime? We want to know what y prime is. Let's draw our graph. This is the line y equals 5 right here. I have a question. What is the slope of this flat line? Hopefully everyone can see that it's 0, right? Awesome. Yeah, people are saying 0 in the chat. It makes sense. So graphically, right, we know that the derivative, this has to equal 0. Why? Because we don't have a slope on our original function. So it checks out and it makes sense. So that is one of the rules. Let's talk about another rule really quick. Actually, I think that is just about everything. Oh, the next rule. Okay, so we have, let me go back and you can write this down really fast. Go ahead and write this down. Okay, so get these 3 rules written down. The derivative of x to the n, that is nx to the n minus 1 power. The derivative of a constant times x to the n, pull the constant out. Now it's just the derivative of x to the n, which we know how to solve based off of that original rule. The derivative of constant is just 0. Boom. I will give you like another 20 seconds to write this down, and then I'm going to talk about what we're seeing here next. So those 3 rules, 1, 2, 3. And 10 seconds. I'm moving on in 3, 2, 1. Speak now, forever hold your peace. Okay, I'm moving on. Awesome. Let's go through one quick example, okay? If I have 3x squared, okay, the derivative of 3x squared is simply 3 times 2, right? Pull that constant down in front. X, 2 minus 1 is 1, x to the 1 power. This is simply 6x. All right. If I'm moving too fast, I apologize. Just go back at the YouTube video, check your rules, and make sure that I'm doing this process correctly. I've been doing this for years now, so hopefully I haven't made any mistakes yet. But let's talk about our next rule. Okay, so this is the generic case. Those rules that I just talked about, okay, that works perfectly for polynomials, right? X squared, x cubed. I think one of the problems I gave you was like x to the 34th over 34. Okay, cool. By the way, 1 over 34, same thing. That's a constant. So I kind of jumped ahead just a little bit, but you can see that's a constant. That's x to the 34th here, right? Those 34s, pull it down, cancel out. You're left with x to the 33 when you take the derivative. Now, what happens if I have x squared plus x cubed plus, sorry, you're like, what is that? That's a 3. More of my lovely handwriting. X squared plus x cubed plus x to the 32nd power, okay? What if y equals this now? Y equals this weird looking equation, or f of x, right? What happens when f of x equals this? Okay, for those of you that seen calculus before, you know that we can just take the derivative of each one individually when it's addition or subtraction. For those of you that haven't seen calculus before, okay, this leads us to our next rule. And I'll write it like this. When you have the derivative, right, d dx, we have d dx of a function f of x plus or minus, right? Because addition or subtraction, they're the same operation. So when you have f of x plus or minus g of x, and that's all that notation means. So plus or minus literally just means you can add them or you can subtract them, or it could be both, right? So when you have 2 different functions, right, you can literally just treat it as this. This is equivalent to saying the derivative d dx of f of x plus or minus the derivative d dx of g of x. What does this mean? This is telling us that if we're adding or subtracting multiple functions, right? Multiple different like functions, see how we have 3 here, right? Yes, it's all technically one function, but in this case, f of x and g of x are just denoting different functions that are added or subtracted together, right? You can take the derivative of each one individually, then add or subtract them to the original function. In other words, treat each term individually, take the derivative of each one individually, and then you can add them and subtract them, whatever sign that was, all back into one total equation. So go ahead and write that down. I will show you the very quick example for this problem right here. What does this mean? What if I wanted to find the derivative of f of x right here? Okay, it's as easy as this. F prime of x is equal to 2x plus 3x squared plus 32x to the 31 power. Okay, so you can see all I did was I treated each term individually and I took the derivative of each one separately. Okay, that is the addition or subtraction rule for derivatives when you're dealing with polynomials that are added and subtracted together. I'm going to go ahead and keep moving forward here unless anyone wants me to pause real quick so they can write it down. Anyone want me to stop or can I keep going? I'll give you like 3 seconds. 2, 1. Perfect. So let's move on here. Very quick example one more time. Okay, let's say f of x equals, oh gosh, not 3. F of x is equal to 3x to the 4th power plus 12x squared plus, let's say, x to the 4th over 4. Okay, what is f prime of x? What is f prime of x? Okay, I'll tell you. It is simply 12x to the 3rd, all right? And I'm just using all of these rules that we've done. So go ahead, if you're not understanding, write this down, go back, check your rules later on, and then see if it checks out. It should. Now I'm going to move on to the next term here, take the derivative of that one individually. This is just plus 24x, right? I pull that exponent down. The 2 times 12 is 24. Then we're just left with x to the 2 minus 1. Now I bring this one down, plus what is the derivative of x to the 4th over 1/4? 1/4 is a constant. Pull it out. Derivative of x to the 4th. That is 4x cubed over 4. As you can see, these 4's cancel out. Boom. Final answer. I'll give you like 3 seconds to write that down, and then I'll keep moving forward here. How are we doing on time? Wonderful. It's 9:40. Perfect. We're almost done with section 3.1. All righty then. One more rule for you. Okay, so we should have a total of like 4 or 5 now. The derivative of e to the x. The derivative d dx of e to the x. Now, I'm going to do one of 2 things here. Okay, I'm going to write down this, and then I'm going to write it down in the u substitution form. Can everyone still see me and hear me? Okay, because I'm having a little bit of connectivity issues. So if you're like, you're freaking out, I can't see you or hear you, I'm having internet issues, but hopefully it should be okay. Sorry, this is your next rule. The derivative of e to the x. Does someone want to tell me what it is? Anybody? Nobody. E to the x. Ooh, people are saying ln of x. Ooh.
Yes.
It is e to the x. Yes. All right. It's as easy as it gets, everybody. The derivative of e to the x is just e to the x. It's the exact same thing. I see some people saying ln of x. That's okay. Yeah, no. The derivative of e to the x is simply e to the x, okay? I understand where people are getting ln of x from, but just remember, okay, if you've seen it before, it's e to the x. If you haven't seen it before, it's e to the x. All right, so if you get a question like this, what is the derivative of e to the x? You're like, oh no, I've never seen this before. It's e to the x, okay? That is simply just one of our rules. I could go and prove it for you. I don't think it's worth our time. So just remember, the derivative of e to the x, I'll say it one more time, is e to the x. Now, let's get you a little confused here, but this is imperative, okay? If I were to give you the e to the 2x, Okay, what's the derivative of e to the 2x? Okay, right away I can tell you it's 2e to the 2x. All right. This might be unfamiliar to some people who have taken calculus before. This is why I want to talk about the u substitution now instead of like later on. So let me see if I can prove the u sub form for you too. Okay, so I know I said that the derivative of e to the x is simply e to the x. It's a little, there's a tiny little difference that I want to talk about real quick. I'm going to talk about it in u form. I'll explain u form in just a second. All right, I'm going to write it up here. The derivative d du. Okay, so now I'm dealing with u's. I can take the derivative of any variable, right? I can take the derivative of v's, u's, x's, y's. Hopefully you remember that so you're not just like, wait, why is it du instead of dx? It means the same thing, just dealing with u's, okay? The derivative of e to the u is equal to u prime e to the u, okay? This is the form I want you to remember. Okay, you're probably familiar seeing the derivative of e to the x is equal to e to the x. Now you're just like, wait, where on earth did e to the u equals u prime e to the u come from? All right, let me see if I can explain it in terms of e to the x. Okay, we said the derivative of e to the x is simply e to the x. I have a question for somebody. What is the derivative of x? What is d dx of x? What is the derivative of just x? Go ahead and type it in the chat here. Really easy. What is the derivative of x? 1. Awesome. 1, 1, 1. Oh, thanks. Number 1 in your hearts. Thanks, everyone. Oh, I'm kidding. Oh, that was so sad. Yes, it's 1. The derivative of x is simply 1. I can write it like this, right? In other words, x prime, right, is equal to 1. Does everyone see that? Okay. What do we have? Okay, we said the derivative of e to the x is simply e to the x, okay? Technically speaking, we have a 1 times e to the x. Does everyone see that, right? Because if it was 0 times e to the x, we'd have 0. But by definition, right, the derivative of e to the x is equal to e to the x. That means it is 1 times e to the x. We said the derivative of x is 1. In other words, x prime is equal to 1. Cool. Let's replace it. Boom. X prime e to the x. Does everyone see it now? Okay, so the reason why I wrote it up here in u form, right? The derivative of u prime e to the u, same exact form as x prime e to the x. Here's the difference now. With u sub, okay, I'm going to go ahead and erase this. Hopefully I just proved it to you so it makes sense. All right, pretend we're working with u's here, okay? So it's the exact same form as x prime e to the x. It's u prime e to the u. The only difference is we are now talking about u sub. Normally, if you've taken calculus, you're used to seeing u sub. You're used to seeing u sub in terms of integrals. We can use u sub to calculate derivatives as well. What I mean by that is u can now equal anything, right? U can equal any function. U could equal x squared. U could equal 2x. Okay, it all depends on your problem, okay? So if I asked you, again, if I wanted you to take the derivative d dx of e to the, let's say, 5x power, okay? This is now e to the 5x. We now know how to solve this. How do we solve it? It's as simple as this, okay? We now said u can be any function, so we label it like this. U equals 5x, okay? If we say u is equal to 5x, we can rewrite this expression right here as e to the u, right? It's called u substitution because all we did was we labeled u is equal to 5x. We said we're taking the derivative of e to the 5x. Now all we're doing is we're taking the derivative d du, right? Because we're taking it with respect to u of e to the u. Oh, almost knocked over my water. We know how to solve this now. Why? Because I gave you that derivative rule. We said the derivative of e to the u with respect to u is u prime e to the u, okay? What is u prime? Well, let's look at our u here, all right? What is the derivative of u, okay? U prime, right, the derivative of u is simply the derivative of 5x. What's the derivative of 5x? Well, we pull the constant out. The derivative of x, you told me, was just 1. This is equal to 5. U prime equals 5. Now we can go ahead and plug back in everything. Do we know our u prime? Yes. Do we know our u? Yes. Do we now have everything we need to solve for the derivative of e to the 5x? Yes. Okay. This is simply u prime e to the u, which we said is 5 e to the u. In this case, I'm going to rewrite that u as 5 to the x. Problem solved. Okay, I know that might be a little redundant for people who have seen this before. I had to go over it just so that everyone's on the same page. Again, if that didn't make any sense, please go back, watch the YouTube video, slow it down a little bit, and see if you can understand step by step how I was explaining everything. That is the U sub form, and that is also the form that is on your formula sheet that I just uploaded to B courses. So if you go ahead and download it, it's all in U sub form. And you can use the U sub form in terms of e to the x, right? Because we said x prime is simply equal to 1. That's all, okay? So you would just say u is equal to x, u prime is just equal to 1. Problem solved, easy peasy. I'm going to keep going. Boom. All right. Now, for those of you that are like, wow, Zach, you're going way too fast. That was chapter 3.1, of which that was only half of chapter 3.1. The other half we covered on Friday. So yes, your math professors are going to go that fast, if not faster. Why? Because they expect you to read the textbook. So if you did read the textbook over the weekend, thank you. If you didn't, that's okay too. Make sure to read that textbook because, again, I know I'm going over things quickly, but it is necessary. So let's take a quick break. Okay, I know everyone's like, oh my gosh, you just made us write super fast. Someone just left. I was like, let's take a quick break, and they were just gone. Because it notifies me. It makes that little noise. It's like, dun 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 dun. Or no, it's has to go dun dun dun. No, it's not up, it's down. It's one note down. Sorry, I also am a music person. I love playing. Well, I've been playing the piano for, oh gosh, how old am I? 16 years now. I've been playing the piano for 16 years, the guitar for like 7 years, and the drums for probably 5 years. So yes, I'm a very musically talented person. Am I bragging about myself? No, I'm just saying, like, I've been around music, so notes bother me when I can't get them right. I don't have perfect pitch though. I wish I did. I still have to use an auto tuner. All right. Hopefully everyone is okay. Let's take like one more minute. So just relax, and then we'll jump into 3.2 here. Feel free to finish up those notes. I know I don't have anything on your screen. I'm just giving you a chance to intake all of that because I'm about to throw at you another 2 rules, but these 2 rules are they're a little complicated. They're not bad, but they're a little complicated. Yeah, question, go for it.
I missed it at the beginning. What unit was the one we just went over?
So that was 3.1. So that was unit 3.1. We are now about to start talking about 3.2. Okay, so 3.1, we officially covered all the information in 3.1. 3.2, we're about to go over right now. Okay, and we're happy. Why are we happy? Because this is the product and quotient rule. Everyone's like, no. Product and quotient rule. Yes, we're talking about those, and we're making great time. So yeah, we're about to talk about the product and quotient rule next. Hopefully I can explain this good to you all. So yeah, that's what we just did. Everyone's like, why are we just pausing and waiting time? Because I'm giving a few people that reached out to me in the chat privately a little bit more time. That's all. But no worries there. Okay, I'm going to go ahead and start talking about 3.2. Before I move on, are there any questions? Sorry, feel free to ask me questions at any point, but are there any other questions about the stuff that we just did? No questions. None. Awesome. Okay, let's talk about the product rule. So we talked about, okay, addition and subtraction, right? X squared plus x cubed. Okay, cool. We know that is, we can take the derivative of each one individually. 2x plus 3x squared, boom, that's the derivative of this, right? So if y equals this is y prime, right? Easy peasy. Oh no, what happens in a hypothetical situation where we have x squared times e to the x? How do we take the derivative of that? Well, guess what? It's another rule. I know, there's plenty of them. It kind of sucks. But the good news is once you have these rules down, calculus will become much more simpler and straightforward, okay? How do we take the derivative of this? We have 2 products here, right? We have 2 products. multiplied by each other, two different functions, right? We know what the derivative of x squared is individually, that's 2x. We know what the derivative of e to the x is individually, that's just e to the x. How do we take the derivative of both of them? Yeah, product rule, right? The product rule. So this is the product rule. I will label it up here at the top. You're like, that's a V, not an R. Thank you. Yeah, I don't know what's up with my writing today, but this is indeed the product rule. Product rule, yes, if you've seen it before, pretty straightforward. Everyone has their different notation. I'm just going to write it this way, okay? I'm going to write it in terms of F and S, okay? We have the first term and we have the second term, okay? So the derivative, d dx, of the first and the second term is it follows as follows. Also, another fun fact, I could not pronounce my L's for like the first 6 or 7 years of my life. So I would always say like in church when we were singing, I would say hallelujah instead of hallelujah. And so I still sometimes mess that up where I cannot pronounce my L's. I pronounce them as W's. There you go. Fun fact about me, right? Anyways, back to the product rule. First times the derivative of the second, okay? So we have first times the derivative of the second. So S prime plus the second times the derivative of the first. Go ahead and write this down for me really quick, and then I will walk you through it. So we have the first equation times the derivative of the second plus the second times the derivative of the first. It's as easy as it gets. In this case, all right, so yeah, keep writing that down. No worries. I'm just going to start labeling this. In this case, our first term is equal to x squared. Our second term is equal to e to the x, okay? What is f prime? F prime is simply 2x, all right? What is our second term? All right, s prime is equal to e to the x, right? The derivative of e to the x is just e to the x. I know I showed you the U form rule. I figured for the product rule, I'll keep it simple, and I'm not going to make it like e to the x squared or some crazy stuff like that, okay? Now, as you can see, I labeled it out like this. If you are like me, I am very, very neat and organized, right? So I like to write out my rules, and I like to write out I like to write out everything. So you can see I have F prime, I have S and S prime, right? Now all I have to do is just plug it into the equation and I'm done, right? I know not everyone works that way. It works great for me. So we have this rule right here in this blue box. This is the product rule, okay? We said, what is the derivative of this first equation? I gave you a rule. I said it's first times the derivative of the second equation plus second times the derivative of the first. Now, I went down here and I labeled them, okay? The first one is x squared. The second one is e to the x. They're multiplied by each other, okay? What's the derivative of the first one? That's 2x. What's the derivative of the second one? That's e to the x. Awesome. We have everything we need to plug back into the equation. Let's go ahead and do that now, okay? First, we have the first term. Now you can see why I labeled it first and second. It's awesome. The first term is simply x squared times the derivative of the second, which we said is e to the x, plus the second term, which we said was e to the x, times the derivative of the first. What is the derivative of the first? That's 2x. Boom. Problem is solved. If you wanted to, you could factor this out, okay? This is simply e to the x times x squared plus 2x. I'm now realizing you can also pull out an x. Let's go ahead and do that. Boom, there goes an x. Now this is e to the x times x times x times x plus 2. That is the derivative. Okay, this is our final answer. That is the derivative of this top equation example up here, okay? Product rule, go ahead, write it down. I'll give you an additional like 20 seconds, and then I'll talk about the quotient rule next, because you're probably wondering, how do we do the quotient rule? I'm about to show you. Any questions? Any questions on this whatsoever at all? Any questions about Berkeley in general? Which coffee shop is the best on campus? Which coffee shop is the best in town? Does anyone not like coffee? I talk about coffee a lot. I also drink coffee a lot. No one. Awesome. Fun fact, the North Side Cafe, in my opinion, has really great coffee. The Golden Bear Cafe, the GBC, has really great coffee too. Someone's going, is that true? You heard the food was bad. Who told you that? I'm kidding. here's the thing about Berkeley food, okay? The dining halls can be hit or miss, okay? I will give UCLA credit. Their dining hall food is better. Okay. I will say this. The dining halls, it's hit or miss. Sometimes it can be really good. Sometimes you're just like, I think I'd rather starve. In my case, okay, that's just how I am. For the most part, the dining hall food, they do a really good job and they work hard, and the food normally tastes really good, and they provide plenty of options. I like their breakfast options better. I'm also a breakfast person. Number two, let's just say this: the Golden Bear Cafe, right? The GBC, that is right. That's to the left. It's right by the front gate entrance. Okay, the GBC is amazing. Oh my gosh, if you can go there for lunch and breakfast, they have probably hands down the best food. You have to use your flex dollars, so your meal swipes won't work at the GBC. But yeah, their food I would say is probably the best on campus, and their coffee there is outstanding. They also have smoothies too, and they have like a whole shop. It's really nice. Um, Someone's asking, is one dining hall better than the other? Yeah, so Crossroads is okay. For the most part, Crossroads is the newest dining hall, and Crossroads, they have a lot of options, a lot of dining options. For the most part, collectively, people agree that Foothill, right, the Foothill dining room is the best. I would also agree because I also lived in Foothill. So Foothill would probably be the best dining hall in my opinion. A lot of people don't go there because unless you live at Foothill, it is a pain in the butt to walk all the way up to Foothill, right? Yeah, Foothill is a hike. But the good news is, if you're an active person, I know everyone's like, can we talk about math? Yes, one more second. The good news is, if you're an active person and you live at Foothill, or if you eat at Foothill a lot, the freshman 15 does not exist for you. I promise. I think I lost a total of like 10 pounds my freshman year, no joke. And I was eating a lot. Why? Because I lived in Foothill. So I was making that hike back and forth every day. I should also say too, I probably stopped weightlifting. Okay, so I lost a lot of muscle mass. So you're like, oh my gosh, am I going to lose 10 pounds? No. Okay. Results may vary. There, I'll put that at the top. Results may vary. Yeah. Anyways, so thoughts on Crossroads Dining Hall? Yeah, Crossroads is pretty good. It's not bad by any means. If you go to Crossroads, you'll be fine. I never ate at the Unit 3 dining hall, or like the dining hall within the units. Good luck at that, I guess. Off-campus restaurants you can use swipes, flex dollars at. Abe's Pizza on Telegraph Avenue, I think, is the only one, maybe. For the most part, they're contained to the dining halls or stuff on campus. Sorry, yeah, crash course on your, yeah, see, this is awesome too. So I know I'm your math instructor, okay, but I also know a lot about Berkeley because I've been a Berkeley student. So I don't want to take up too much more time because this is the recording, but tell you what, after, if everyone wants to stay after, I will go ahead and talk a little bit more about the dining hall experiences, Berkeley in general, any questions that you have. I'm also here every single morning at 8:45 for office hours that I think everyone forgot about or just doesn't want to wake up for. So yes, I am here for you every single morning for the next 3 days, especially on Thursday. If you want to ask me some last minute questions at 8:45, feel free to come hang out and chat. Awesome. Yes, I will get to your question, Emmanuel, in just a second, but let's move forward. Sorry about that, everyone. You're just like going to write me a nasty review. Like, he always went off topic. I think I've done a pretty good job for the most part of staying on topic throughout the course of math. I will say this though, a lot of your professors will just, they will take off in a different direction and be like, oh no, sorry, I forgot to teach you like half of the book. Feel free to teach it yourself. It sucks. Yeah, rate my professor. It'll help you in the long run. Let's talk about the quotient rule. Okay, so up to this point, we've talked about x. We've talked about functions adding or subtracting together. Okay, we take the derivative of each one individually, right? So f of x plus or minus g of x. Okay, we can take those individually, then add or subtract them back in at the very end. Okay, we said this is f prime of x plus or minus g of x. Cool. We just talked about the product rule. The product rule, we basically said first and second, okay, the derivative of that is first times the derivative of the second plus second times the derivative of the first. As you can tell, I have done the product rule many times in my life. Remember this formula. I taught it to you this way. I think on your formula sheet, it's like A and B, okay? It means the same thing. Sometimes it'll be U and V, okay? Letters doesn't matter, the formula stays the same, okay? Let's talk about the quotient rule now, all right? Let's talk about the top divided by the bottom. All right, the derivative of the top and the bottom function. Let me write it like this: d dx of, yes, that is a d. I apologize. The derivative of the top. Okay, we have the top divided by the bottom function now. All right, what is this equal to? So if you're following along in 3.2 of your textbook, this is page 186 in your textbook. Probably should have said that a little bit earlier, but it's as follows. You have the bottom, okay, times the derivative of the top. Okay, so I'll call it t prime minus the top, okay, times the derivative of the bottom all over the bottom squared. Yeah, Kamani, I'll get you that textbook link. Yeah, I don't know why the link disappeared, but if anyone needs the textbook link, I got you covered. So let me finish this out. All over the bottom squared. Sorry. So bottom squared. Okay. Remember this equation now. Boom. The derivative of the top divided by the bottom, otherwise known as the quotient rule. Oh, thank you so much, Emmanuel. Go ahead and check out that link. Tell me if it works, Kamani. Quotient rule. This is the quotient rule. We talked about the product rule. This is now the quotient rule. All right, write this down. I'll give you a few more seconds, and then I'll go ahead and give you a quick example. Bottom times the derivative of the top minus top times the derivative of the bottom all over the bottom squared. Perfect. Again, your textbook uses functions. G of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. I think it's much simpler to just use letters and just let you know, hey, these letters represent the equations, right? Your textbook is a little bit more definitive in how they define their functions, right? All I'm doing is just using letters, so that way in your head, you can recognize when to use the quotient rule. I think everyone's got this written down. I'm going to go ahead and do a quick example. Let's take the derivative of x squared divided by e to the x. You're like, wait a second. We just dealt with that, but it was the product rule. Exactly. I'm trying to give you easy examples so that you can go back, look at your notes, and be like, oh, okay, I see what he did there. X squared over e to the x. I'm just rewriting it. Let's take the derivative, d dx. All right, let's label everything. What is the bottom? The bottom is equal to e to the x. Sorry, that looks like a z. Again, e to the x. Cool. What is the top? The top is equal to x squared. Cool. Let's write out our derivatives right now. What is b prime? The bottom is simply b prime is equal to e to the x. Okay. What is our t prime? What is the derivative of the bottom function, right? That's all I'm doing here. T prime is equal to 2x. Okay. By now, hopefully everyone can see that. I know that we're using all these rules that we just learned all at once. My goal is that by the end of today, you will be able to at least accomplish some basic product and quotient rules. Let's go ahead and plug in everything, okay? We said that the top over the bottom, the derivative of the top over the bottom is as follows. We have bottom times the derivative of the top, so t prime, minus the top times the derivative of the bottom, right? B prime, all over b squared, the original b squared, not b prime squared. Okay, I should note that. We have everything, we labeled everything out, we calculated it. All we have to do now is just plug it into our equation. We are done, okay? What is b? We said b is equal to e to the x. Okay, this is equal to e to the x times t prime. What is t prime? We said that is 2x minus the top. What is the top? That is simply x squared times the derivative of the bottom, which is also just e to the x, all over the bottom squared. What is the bottom? E to the x. Cool, squared. E to the x. Let's go ahead and square that. Boom, we're done. All we have to do now is simplify it, okay? Like so. Go ahead and simplify this. In this case, I'm going to pull out an e to the x from everything. So I'll rewrite it like this. I'll rewrite it down here. Does everyone see I have an e to the x in the top here, okay? And I have e to the x squared in the bottom, right? So I have 2 e to the x's in the bottom. Here's what I'm going to do. I'm going to factor out an e to the x and an e to the x from the bottom. Those e to the x's cancel out. I'm left with 1 e to the x in the bottom, okay? So again, I'm factoring out an e to the x okay? I'm factoring out another e to the x from the bottom here. Those cancel out. This is e to the x over e to the x. Boom, cancel out. Now we are left with this equation. Oh my gosh, I keep deleting that. Let me write this back in. Now we have 2x minus x squared all over e to the x. I'm okay if you leave it here. If you want to factor out an x, go for it, okay? I think for the sake of factoring, we'll do that. So this is 2 minus x. This is x times 2 minus x. Boom, problem is solved. So again, hopefully you got to this point, right? Go ahead, take a picture of this. What time is it? It is 10:08. I will go ahead and stop there because I think we covered a lot of material. I don't want to throw anything too more complex at you. This is some really good stuff. So again, the quotient and the product rule, I gave it to you in terms of substitution method, right? Top, bottom, like T's and B's, and I think the other one was first and second, okay? You just substitute in what's the first term, f equals, okay? Take the derivative of it. F prime is equal to this. So you can see we're already using the substitution method. That's why I wanted to give you the e to the x derivative in terms of u prime e to the u, okay? That's why, because substitution happens all the time. Why? Because if they gave us just basic derivatives, everyone would get an A, and Berkeley doesn't like that. Berkeley is like, that, yeah, I'll talk about that after I stop the recording. Let me go ahead and give you some homework real quick. From section 3.1, let's give you some not too bad problems, okay? I'll come back to that section 3.1. Your homework for today. Everyone, I have all 45 of you here. I know some of you have never turned in homework at all once. That's okay. It doesn't bother me, but please, okay, if it counts now. In terms of this is where you should start getting some good practice in. So even if it's just practicing submitting your assignment, I would really appreciate it if everyone could at least attempt to turn in something. So that way, when we get to Thursday, right? Because Thursday, it will be a timed practice midterm. So I'm thinking I'll give you like 30 to 45 minutes. All right. We'll talk more about it on Wednesday. I want everyone here by 9. I want to start by 9. Okay. Most of your classes will do that too. So they'll start right at 9:05 at the latest. And I'll give you like 50 minutes to do it, maybe 30, depending on how hard I make it, okay? So that way we can like just chill and hang out for the rest of the time, okay? So maybe I'll give you like 45 to 50 minutes to do it and another 5 to 10 minute window to turn it in, and then I'll close the submissions. So that way it'll be just like an actual practice midterm that you would have to submit in a given amount of time. So just practice submitting this assignment, right? So that way when you get there, you're not just like, oh my gosh, Zach, I wasn't able to submit it on time because I didn't know how, and then you're emailing me your test, and now I'm having to go through my email, which I get like 30 a day. It's horrible. Fun fact, don't use your school email for like other email sign up stuff where it's like, use your email. Don't do it, because then you're like school email. It's a mess. Anyways, yeah, so just practice turning in this assignment and tomorrow's assignment. If you can, that'd be great. I'll also make sure to get that feedback to you and everyone else's feedback for all the other assignments. But yes, 3.1, I promise you, really straightforward. Let's go ahead and do number 3, okay? Let's also do number 7. Let's go ahead and do 15. 15 is easy. All right, for 15, I'll say this, okay? Factor it out. Use the FOIL method. Use the FOIL method, factor it out, and then you can take the derivative term by term by term by term, okay? If you already know how to do the quotient rule, or not the quotient rule, if you already know how to use the substitution method rule, okay, and you want to do that, that's okay too. I'm okay with that. So if you want to try the U sub method, go for it. Otherwise, FOIL it out. That's how you do number 15. And I'll give you like one more easy one. Let's go ahead and go with, I'll give you an e to the something here. Okay, we talked about it. Let's do number 4. So number 3, 4. All right, so a total of 4 problems. 3, 4, 7, and 15 from sections 3.1. Awesome. I'm telling you, it'll take you like 30 seconds. You can do it in your sleep. 3.2. Let's talk about 3.2 here. 3.2, let's go ahead and do... Number 3 is a good one. All right, so number 3 from 3.2, that's a good one. It's a little bit harder, but not by much. let's go ahead and do number 5 because that is very similar to very similar to what I gave you. And let's see if you would like to also attempt. All right, I'm going to do this. Hopefully no one hates me for it. Let's do number 23. Okay. Number 23, quick side note. Okay. Number 23, you will have to use the quotient rule. Okay. But while using the quotient rule, that looks like a Z. While using the quotient rule, okay, you're going to have to use the product rule inside of the quotient rule. You'll understand more when you see it, okay? Just keep a reminder for that. Again, write out your formula, write out the formula for the quotient rule, then whatever the top and the bottom is, okay? If the top, in this case, I believe number 23, the top equation, okay, to take the derivative of the top equation, the only thing that changes is you have to use the product rule to take the derivative of the top function only. That is it, okay? So write out your equations, see if you can work through number 23, okay? If anything, if you're going to do any problem, okay, you're like, I don't want to do all these problems, 3.1 will take you 2 seconds. Number 3.2, if you're going to do any of them and you just want me to grade one problem, number 23. Why? Because that incorporates just about everything. So number 23, try and do all the other problems, okay? But if you're only going to do one problem, do problem number 23. Awesome. I will say this, I will make one of your test questions very similar to number 23. So go ahead, attempt number 23. Why? Because Thursday, something very similar is going to show up. Awesome. I am done. That is everything. So 1, 2, 3, 4, 5, 6, 7. Yes, I gave you 7 problems. It's still equivalent to about 3, okay? Because I'm telling you, these 4 problems, it'll take you 30 seconds. These 3 problems probably take you about 2 to 3 minutes a piece. 20 minutes max. If you're spending over like 20 minutes on the math, feel free to join office hours or just like, come talk to me in the mornings. Other than that, it is 10:14. I finished with 1 minute to spare. Look at that. I am an expert on time. I'm kidding. I'm horrible. I show up late to everything. That's all I have for you for today. Thank you for hanging out. I will be here for questions and I will go ahead and stop the recording now.